Hey, so today I'm going to give a walkthrough of the monitoring stack that we have at Arcadia Power here. I'm going to talk about a bunch of different components, the things that go into that. Yeah, kind of the end goal is to spread knowledge about how this stuff works, and really this is kind of a tool set for developers and engineers to gain more insight into the software that we build and operate. Yeah, so let's kind of get into it. As an overview, um, gonna talk about a number of parts of this, and like I said, it is kind of an ecosystem. So there's a lot of components to this. I'm gonna try and walk through each one. We'll talk about kind of how this is all presented, which is at monitoring.arcadiapower.com. We'll walk through there a little, and then I'm gonna give kind of like a high level diagram of all the way this system works, and then we're going to walk through each component of that. Kind of those big components are Grafana, Prometheus, Telegraph, StatsD, and then the actual Ruby code that we write. In some ways, this is kind of the like backwards way of presenting the order. So this is the opposite way that data actually flows through it. But I think it might be a little clearer. I think it might be a little clearer this way. We'll see. Hopefully that's right. Yeah, so kind of the first thing here is if you go to monitoring.arcadiapower.com, so this is Grafana, which is basically the front end of our monitoring and instrumentation system. Grafana is an open source piece of software, and basically you can plug in different data sources. The ones that we use, might as well just show you. So different data sources, and we use Postgres and Prometheus are the big ones. We'll get into what Prometheus is, and for our cases, this is just pointing to our Emperor Penguin Postgres follower. Yeah, and what Grafana does is basically, you have these inputs, and Grafana is a view layer. So I'll show you some of the views we have. We have a dashboard for Macaw. It shows us, numbers that are important. Kind of one of the original things that we really cared about was the question: are our scrapers actually running? We queue up all these jobs. Are they actually running? So that's one of the first things that we're able to answer with this. You can see in the middle of the night we queue up a bunch of jobs. We run through it. It goes down. We have things like the system stats. So we run Macaw on Docker containers. This keeps track over time how much memory, how much CPU those containers are using. That's useful knowledge for us when we do new scraper types, or we're worrying about capacity, or like weird restarts or that kind of thing. That data is useful to us. We record numbers like how long it takes for scrapers to run. So that some of these are slow, some of these are fast. Yeah, so, we won't go into everything, but those are kind of the things that we can present. So let's see. So that's our Macaw dashboard, and we also have one for Emperor Penguin. Kind of shows us general numbers, things that we care about. Grafana is visible to the whole company. All you need is at arcadiapower.com. I think if I wasn't signed in, let me see if there's a sign out button here. There may not be. Wait, yeah. You can sign out. It'll look like this. All you do is sign in with Google and specify your Arcadia Power account, and you can get in. Then the way Grafana is set up, these dashboards are actually, their configuration is saved. You can click around, you can change things. You can go into a specific graph. You can change the time frame on it. If you want to see the last 24 hours instead of the last 12. You can really do whatever you want with these. And then if it's a change that you want persisted to that dashboard, you go into the save dashboard. You can give a little note about why you changed it. Yeah. So the way that each of these things work, like I said, this is kind of a presentation layer. If you go into a thing, you can see the queries that it's running to generate these. A lot of these are driven by our Prometheus data, which I'm going to get into a little more later. But basically, these are the queries that it is graphing. So you can go in, you can see, you can edit those, try and get the data you like. Another thing that might be useful to see. So we've seen a lot of graphs so far. Like I said, most of which are Prometheus data. We also have tables, which are pretty useful. Just a different way to present data. So a good example is these scraper metrics. So these are tables, not graphs. And if you look in to the edit, these are actually getting data out of the Emperor Penguin Postgres database. So yeah, you can see the SQL we're using to get this stuff. I wish it would show me. Query inspector. No, not that. Right, so you can see it sometimes takes a little bit to load up, but you can see the generated SQL. Grafana lets you use some macros in here. I think the main one we're using, this will be a little hard to pull out because these are pretty large queries. Is kind of just this time from and time to, which is based on the time frame that you set up here. We're just using that to query parts of the data. So let's see how to make a dashboard, tables versus charts, versioning. So all those dashboards are like I said, are versioned. You can make changes, and we can always go back if that's necessary. Versioning is particularly important kind of for these queries. Like we have this pretty complicated SQL query in here. If you change that and it doesn't go well, we can revert a version, which is very straightforward. So let's see if we go to settings. And then just versions, you see the things that changed in here. You can go back and restore them. Which is just to say that these things are very changeable, and this data is relatively durable. So as you might guess, all this querying is actually happening from the Grafana server itself, not off your laptop. There are different ways you can configure that, but that's how we have it set up. And so this is going against our Postgres follower. Obviously, because we assume these are going to be kind of heavy queries, and we don't want to impact the application at all. Let's see. Yep, you can make changes. And we might as well look at one of what's a good example graph here. So this is I guess a good example of kind of a Prometheus dashboard. This is kind of just an example one. So if we look in here, this is a Prometheus query. Let's do that. So we've talked about Prometheus a lot. What is Prometheus? Prometheus, and I'll just drive by their lovely website. Prometheus is Prometheus.io. Prometheus is a data store that is designed around monitoring and kind of metrics. This is, I think most engineers are familiar with kind of SQL-based data stores, and then there is this universe of NoSQL data stores, which I guess in some argument Prometheus would fall into that umbrella. Kind of like the use cases that it's useful for is basically like you want to constantly record data about state, things like what is the CPU usage of this machine over time, how long does like every request to my web application take, things that you're going to be writing dozens, hundreds, maybe thousands of times a minute. This is a data store that's designed to be able to do that at a high scale. You wouldn't want to write a row to a Postgres database for every single request your application gets. That would slow things down. That's just not really a scalable thing. So Prometheus is kind of is focused on that. So we'll kind of get into the specifics about what we send to it and how you can choose what data goes in there. It is kind of there's a lot to learn about it. I really recommend going through the documentation. It has a pretty good overview and kind of like particularly I think is useful, and something I refer to a lot in this section is just around querying, how you get data out of it. I'll walk through kind of some example uses, and maybe one other thing before we get into that. So yeah, kind of the things this are useful for, like data we want to write a lot of, data we want to ask questions like, okay, what is the average time for a request? So if we log the how long every request takes, Prometheus can give us a very quick answer to, okay, what is the average time for a request? What is the 90th percentile time for a request? It knows those things very quickly, just kind of by nature of how the data store is designed. Yeah. So let's see. There's certain. That makes sense. So yeah, maybe I'll show the. There is a web interface to Prometheus. It's not necessarily helpful for me to share the address, but it's at the. If you go into our EC2 web UI and get the IP, the like public host name of the machine this runs off of, and you go to 9090, port 9090, you'll get this web interface. I should note that I think we have that that security group whitelisted to the office right now, but I've also been known to change that to make it accessible from elsewhere if that's a thing people want to do. Yeah, so this is kind of the web UI. There's some useful things in here. So one of them is that we can take a look at is targets. So the way that Prometheus works, and kind of in the monitoring world, there's two approaches to getting this data. You can either push data to Prometheus. So that's kind of the way that we're used to. I want to write this row to a SQL database. I'm going to connect to it. I'm going to tell it to write this, and it's going to receive that. Prometheus is designed to work with dozens, maybe even like hundreds of machines writing data to it. So the way that it actually does it is a pull model. So if you look in the in the configuration, and this file is defined in the monitoring repo. There's a lot more details about kind of this level of administration, but yeah, these things are configured there. But basically, we give Prometheus, a list of IP addresses or machines, and it goes to this /metrics path. And so on an interval, every 10 seconds, it goes to that page, and it pulls down those metrics and puts it into its database. And then Grafana is querying against that database. So let's look at some of the, So these are some of the targets, for example, that we have Prometheus configured to right now. We have, data from Emperor Penguin. We have it connected to Grafana to get, metrics about Grafana, which is always kind of neat. The big one is data from the 3 Macaw servers, and then it also pulls data from itself. So one of the cool things about this, for example, if, we roll something out that causes, and we've seen this, Macaw to go down. It'll try, so that server disappears, and it tries, within 10 seconds, it tries to go to that, hit this URL, and it finds that it's not available. So we know that instance went down, and we can, set up, and we do. So let's see, in our Macaw database, we have this host health check, 3 healthy hosts. It's pretty straightforward. We can look at that query. All it is we look for, there's this up. So that's a good example. So in this Prometheus web UI, you can, you can write queries, get data about it. So one of the metrics names will be up. So we can look at this and it writes to this every time it scrapes one of these endpoints. One thing about Prometheus's data model is so it has metrics, and metrics can have many labels. Kind of the nuances of how it treats that are a little interesting. I suggest reading the documentation around it. But for our purposes, we can say the things that are in these brackets are the labels. So if we have this up piece of up data metric, we know that it belongs to this instance and kind of what job. So, we say that these 3 instances belong to the macaw production job. So that allows us. So if we say, if we want to know about the up metric for job equals macaw production, it can tell us that. And the other kind of Prometheus treats metrics as vectors, which is going to sound very confusing. But kind of what that means is, so you can have instantaneous vectors like it's showing us right now, or you can ask it for things over periods of time. So this will give us this metric over the last 12 hours. So, you can see we've got a lot of these. It just gives us those counts now. So maybe something else that would be useful. So let's see, we have action or Docker container CPU usage in kernel mode. Yeah. So this is like an example of the data we're getting out of Macaw. Like I was saying, we monitor the Docker stats there. So obviously this gives us a lot of values, but we can you can tune these labels to start to get what you care about. So good example, let's see, container image. Yeah, if we only cared about, say, our file beat image, we can apply labels to only get that. And then if we want to look at that over 12 hours, we can do that. Not great in the console, but we can also pop it into a graph here to kind of see it. Yeah, and so all these, I kind of go into this mostly to say there's a little interface for asking these questions, and some of the kind of things that you can get out of here are pretty useful. We have these rescue stats kind of for Macaw. One of the kind of neat ones. So we have this set up on both Emperor Penguin and Macaw. And we have it set up so that every request that comes in will write something out to Prometheus. So in this dashboard, we can use the same query, and there's in part of the Prometheus query, and then you can do this by thing. So in this case, by the application label, and we're doing a sum over time. Here, maybe we can walk through it this way. So we have this query, process action. It's kind of weirdly named, but process action controller seconds. If we go into the Prometheus console, we plug that in. Here, we can even do it without. So this is the data that we're getting for each kind of job. For example, here's one from Emperor Penguin. We know what controller it's going to. Admin track sources. We know what the status code of it was. And so kind of by nature of this metrics, this isn't how long those requests took, but it's how many times we got that metric in this time frame. So we can see we got 6 of these to the emails controller, for example. So if we want to look at that over the last minute, we add this 1 minute vector to make it a range vector. So we start seeing kind of groupings of that over time. I gotta look at my crib notes here because this querying is not always intuitive. So if we want to look, we can then, because we have that range vector, we can get the sum over time of that. So it starts grouping those things into more useful chunks. We can say, okay, well, we know we got 13 of these to the Griddle emails controller with this particular status code. And we should see in here, so we have things from both Emperor Penguin and Macaw. And then we can do the sum of all these by application. Let's see if I do this right. Yeah, which just gives us it collapses all that stuff from before into just kind of each application. And this is just kind of a nice thing. It lets us build dashboards using across apps with a pretty similar interface. And you can imagine situations where we might want to look at things this data across both applications. Yeah. So let's see. We talked about push versus pull. We talked about labels a little. We'll get into labels a bit more maybe once we start looking at kind of the application level things. I think probably two other important things to talk about for Prometheus. One this is not a long-term data store. Really, by design, you want to be able to write a lot of things, and you want to see like this is the turnaround on it's very fast. It's pretty relatively scalable, but right now it's only configured to hold I think 15 days worth of data. There are some things we could do around long-term storage, but really this is designed to give you information about your systems right now, either like things at a glance so you can tell what the health of your system is, or if things go bad, you want to be able to have data about components of your system to be able to answer questions about what's happening. So like a good example of this on the Emperor Penguin dashboard, we can see, so we have these status codes kind of broken up by minute. And this is pretty similar to the other one. We're looking at some of things over time. We use this as a label, so we're matching against things that are not in the Jabru API, which is basically everything else, in the and then we look at it by status code. It just gives us the requests per minute that are going on. You can kind of see the ebb and flow throughout the day. You can see the admin things start to pop up. So in the middle of the night, you can see we start getting this spike around 3 a.m. When we're getting callbacks from the scraper jobs that we trigger. You start to see the admin things pop up kind of in the 9 to 5, and then you see the Jabru API, active throughout the day, all throughout the day, but mostly kind of during normal 9 to 5 hours. We can kind of look at that also. So we also get some stats about Postgres in here. We can kind of see, and this is kind of the rate of tuple change. So you can see there's like a lot. We can break out fetch, inserts, deletes. If you're doing some kind of background processing job that's going to involve a lot of writing, you can see how that responds in here. That kind of just lets us answer questions like, okay, is there an odd amount of database activity happening now when people are complaining about slow activities? Which, we can also see. I think I mentioned earlier, Prometheus is good about kind of breaking things out. So like, for example, we can get the upper time for one of the metrics. So, if we get 5 requests to the admin user's index controller, and one of them, it keeps track of both the average and the maximum of that. So, the max one's going to be 24 seconds because that's basically the timeout on Heroku. This is, provides an easy way to kind of get that information out. Yeah. Okay, so let's see. We talked about durability. So data types. There is a pretty good page in the Prometheus documentation about this. The metric types. Kind of for our purposes, the main one that we use is these there's gauges, and then counters. So counter is exactly what it sounds like. It's a counter. You just count up. There's gauges, which is kind of like something that'll keep a value. So if you say the value of this metric, maybe we want to. So one place we use this as like the queue size in Macaw. So when we write it, we say, okay, there's 10 things on this queue right now, and it holds that value until the next time you send it, and you say, okay, there are 9 things on this queue now. Those can be useful. There are some other kind of, I actually have not used the histogram or summary, but those could be pretty useful too. Again, encourage reading the documentation around each of those. Oh, I'm sorry. I got a little ahead of myself. I think I should have broken into this diagram. So let's go ahead and do that now. So we've seen Grafana, we've seen Prometheus. This is kind of the high-level overview of all this stuff. So all that stuff is living on the monitoring Elastic Beanstalk server. That's configured, in this monitoring application I showed off earlier or pointed to earlier. So on that server, we have the Grafana. We have a container running Grafana. We have a container running Prometheus. And then we have a container running Telegraph. So Telegraph is, and I wrote this down because there's a good one-word sentence of it. It's a plugin-driven server agent for collecting and reporting metrics. Kind of what that means. So it's a program that runs. We set a config file, and the reporting metric we care about is Prometheus. So Telegraph serves up the web page that I was talking about, that Prometheus scrapes every 10 seconds. So this page here, which is not going to work. This might work. So the page, I don't think this one's going to work because of security groups. Oh, cool. This one will. So the Telegraph is running this page that Prometheus scrapes its metrics from. It's a text thing. It looks like this. Obviously, it's like a little inscrutable to read, but you can start to see. I can make this a bit bigger. This one, since this is the Grafana one, it's not super useful to us. But you can see kind of the names of the metrics, and these are the labels. It's got handlers, it's got a status code, and then the metric value. So like I said, Prometheus has a pull model. Telegraph is running that server. That's the reporting agent that we're using. So the other part of that for Telegraph is so that's the reporting plugin, and then we have collection plugins. So the two that we use are StatsD and Postgres. The Postgres one really just connects to a Postgres database and gets some stats out of it. That one graph I was showing earlier about the tuples changing, that's what drives that. And the main one we use, and this is probably confusing, but we use StatsD as the maybe transport mechanism is the way to think of it, in between Rails and Telegraph. And the reason for this is it's not really the way that we run our Rails servers. It's not really practical for us to have Prometheus scrape them directly. So a good example of the reasons why are one, kind of on Emperor Penguin, we don't know what we would need to run an additional process and send things out to it to be able to scrape that. On Macaw, if we wanted something to get data out of the background workers, it has to send that to somewhere that would also be long living, which doesn't make sense. And Telegraph is kind of just a good model for this. And we use StatsD to communicate from Rails to Telegraph. And kind of the reasons for using StatsD are that its metrics map very cleanly onto the Prometheus, or the data types map very cleanly onto the Prometheus ones. There's a counter, there's a gauge, and you can send timing values. Those are kind of the big ones. And the other reason is that we can send data to StatsD over UDP. UDP, as opposed to TCP, is a non-blocking protocol. So there's no performance impact to sending that out very frequently. And if the Telegraph server goes down, it's not going to impact the Rails server. And kind of in the same way, that's another benefit of Prometheus's pull versus push model. If the Prometheus server goes down, it doesn't impact any other service, which is nice. If something was trying to write to it and it wasn't there, that would cause problems. Okay. So Prometheus lives there. It talks to these Telegraph containers that run on each Macaw server. Both the Rails server and the rescue workers send data off to the Telegraph, and Prometheus just scrapes those out basically every 10 seconds. Let's see. We talked about that. I guess maybe one useful thing to know about Telegraph. So because of the Heroku's process model, the one for Emperor Penguin does run on the monitoring server, and we send data out to that. Whereas opposed to on Macaw, we run it on each server. Yeah, so the configuration for the Macaw ones lives in here we go, in the config/telegraph. I don't think there's maybe too many reasons to have to change stuff in here, but it might be useful to know. Like I said, this is just where we configure the input plugins. You can see it's looking at the Docker socket to get the information about Docker, and then how we have statsd configured. It's going to receive data over UDP, et cetera, et cetera. Yeah, so we talked about statsd, why we use the UDP. Okay, and then kind of the final piece of the puzzle is the Rails instrumentation. So in both Arcadia Power and the Macaw applications, we have this lib Prometheus metric file. This probably should be into a common gem, but it's also a pretty small chunk of code, so I haven't done that yet. And basically all this does, we got a little class. We can send it a timer value, a gauge, or a counter. And really all it does is it uses the statsd gem to send it to, and statsd hostname goes to the whatever telegraph instance we have it configured to. So it just sends that data over to there. It's pretty straightforward. I mentioned this mostly because we can use this Prometheus metric class anywhere we want. Yeah, we'll talk about that again in a second. So the number one place that we use it right now, Rails has this thing called active support notifications, and the important ones that we listen to are, there's one for process action in action controller. So every request that goes to an action controller, it'll hit this notification. And you can get some data out of it. The ones that we look at are kind of the controller, the action name, and the status code of that. And we send that as a Prometheus timer with the number of seconds, so that we know how long every request that came in took. Hopefully pretty straightforward. And we do the same. There's metrics around active job. Kind of the idea just being, this is the easiest kind of Rails way implementation of getting data every time one of those things runs. So we, like I said, we look at the args on that. We kind of parse it out. So these are the labels, and these do end up mapping to labels in. Let's see if I have a tab open with this. Ooh, I don't think it likes my zooming. Nope. Right, so these map to the controller and action labels that we have in Grafana here. Is where those come from. Cool. So we got that. We got labels. Right, and so these active support notifications are the only place we're using these Prometheus metrics right now, but they can be used anywhere. Some other places that could be useful, we could do numbers around user conversions, billing conversions. We could put these into access state machines anytime one of those states change. We increment increment a Prometheus metric with the new status name. We could do this around timing for how long certain things take. For example, in the Jabru API, we have this glob method that we're always a little curious about the performance about. We can put a timer around that and report it and have good metrics around that. Kind of all useful data like that. So let's see. That's Rails instrumentation. Maybe I hope this diagram is useful. I'm trying to think about other questions people might have. So kind of the big goal here is we want this. I want this to be available as a tool for people to know what's going on in the systems. Know that we can get data around some things that are pretty useful to us. And like the way I often think about this is questions that come up, like if there could be a dashboard that I could look at that would answer that question right away. The scraper metrics are a pretty good example of this. And like I said, these are totally separate from the Prometheus stack, but rather just going through Postgres. But being able to have data that tells us about how our software is working is pretty useful and important. Yeah, I guess we have those. Got these. Yeah, I think some like useful stuff to do is always just poke around in these. Unless you're hitting the save button, it's pretty hard. You're not going to break anything. I think this stuff has been useful. So a good example, we still have this great API kind of hanging around, and we have. If we look at this, all we're doing is we're looking at this a metric that only the Grape API is writing to. It lets us just know that that's still being used. We can't delete it yet. When we were converting over to the Jabru one, we could see that the new one's actually getting used, how performant it is. Kind of just hopefully general stuff about this. The upper controller response times is useful when people start complaining about the admin panel being slow. And, it's a quick way for us to be able to go in, look at the max time on here, and we can say, nope, not that way. There we go. And we can know that the admin users controller index and the billing queue controller are the prime things to look at there. Yeah. So hopefully that's a useful overview. Let me know if there are any questions, and I'll try to answer them while I can. All right. Thanks, guys.